Central Europe. It's 5 o'clock your time. It's 4 p.m. in the UK, and it's 10 a.m. Central in the USA. Welcome to you all. Now, Tissue World has been with you since 1993. As you know, it's a unique platform where people in the industry meet, learn, and do business. And the digital version that we're experiencing now is going to do that just as well. It's all about embracing transformation and discussions around how tissue can thrive in these very turbulent times. Designed to bring you as close as possible to a tissue world as we once knew it in these new and different times, the pandemic has obviously caused many people to postpone events literally around the world. But not us. Here we go with 3 days of matchmaking here on this platform that started today, following up with the next 2 days as well, along with these plenary webinar sessions that we have scheduled for you. We also have on the Zoom platform both Q&A and chat enabled. And if you're interested in chatting with any of the panelists or contributing with a question or a comment, our sessions expert moderator, whom I'll hand you over to in just a moment, John Holton, will monitor all of those. So feel free, folks, get engaged and send through your questions. A little later, after we've been through our workshop discussions, we'll have some polling questions for you. And I'm going to be taking those through with you as well at this session. You'll need a smartphone, a handheld device, a tablet, whatever it may be. They're very simple, but very interactive things to do. And I'll share that with you a little later. So as a heads up, if you're just joining us today for the first time, we're approaching over 1,000 delegates now registered for these digital days, and across the conference, people are attending like yourselves from all over the world. At the last count this morning, when I saw the data, over 40 countries represented: Europe, Africa, India, Australia, the Middle East, and of course the USA. And these people are the creme de la creme of the industry, from across the C-suite through to executives and directors, engineers, there's some researchers, and we even have technicians making sure that the industry is fully represented. We've got suppliers to the industry, integrated tissue products makers. We've got converters, jumbo roll makers, machine makers, and even retail and distribution people, to mention just a few. I'd like, if I may, at this point, to thank our key sponsors who've helped us bring this platform to you. Of course, our platinum sponsor, Solar Turbines, and our gold sponsor, Buckman. So let's get to the agenda itself and the focus for our second webinar session of today, having focused earlier this morning on the Asian market, is now much sought after the Yankee Dryer Workshop, focused on troubleshooting and, of course, problem solving. We're very honored to have with us an expert in this field to lead this workshop and to moderate the panel discussion. Mr. John Holton, who heads up the tech support at Tosco Tech North America, is in charge of technical support there with over 35 years experience in the tissue industry. He's been involved in tissue production and maintenance, in engineering management. He's been a TAD startup manager and full on Yankee services as well. His organization, Tosco Tech, as you know, probably is a Voith company, now in the USA, but they were founded in 1948 as a service provider for paper mills in Tuscany, Italy, where they began engineering and producing the first complete machine for paper manufacturing. They were also the first company to manufacture dryer cylinders in steel instead of cast iron. John's here to introduce our gold sponsor, Buckman, and then give us an overview of Yankee Diagnostics himself before he then introduces the presenters of our workshop to you. John, welcome, sir, and over to you. Good morning.
Good morning, and thank you, Michael, and welcome, everybody. Good day. It's going to be an exciting session for Tissue World. This is the first online session, and when Miami was canceled, this is an abridged version of that conference. Before we get started with this exciting session, we've got 5 presentations, and then we have some real life Yankee problems which have occurred in the industry, and we're going to test everybody to see what solutions they would come up with in the same exact scenario. Okay, before we get started with that, let's give a thanks to our sponsor, Buckman.
Hello, everybody. It seems we lost John. John, are you here?
I just got back.
Okay, so we continue with the original schedule.
Okay, yeah, thanks. Sorry about that. It's technical difficulties here, and well, let's just see if I can share my screen and we'll get going from there. Okay, has everybody got it? Okay, so we have started. All right, everybody. Today we're going to have 5 sessions, and at the end we're going to have 5 questions and answers of real life problems. And at the very end, we're going to have 8 possible voting opportunities where the audience chooses the one and only option. The boss says you have no money, you can choose one option and you better get it right. And then the audience will vote on which of those 8 options would be the best solution if you only have one chance to solve the problem. So I'm going to quickly go over several typical diagnostics techniques. Those techniques will be coupled in the end in order to give you 8 options, 4 from our speakers, and then 4 from the discussion I'm about to have. So let's get started. I'm going to talk just about common forms of non-destructive testing. So very common inspections that we all do, and you may want to think about the or take notes about what they all are, because there's a lot in here. But the external inspection, that would include pie taping, total indicator runout, or TIR, surface roughnesses, mapping of service damages, inspections for crevice corrosions, chatter, or chop. The next common inspection is an internal inspection, where you might check for corrosion, straw clearances, riser or header cracks or holes, looseness of fasteners or balance weights, fastener retainers, plug straws, or spigot fit. Ultrasonic testing, something very common, normally every 5 years, for cracked bolts or screws, thickness of the part, if the identical reference material is available. Magnetic particle testing, where you would look for surface cracks or subsurface discontinuities. For steel Yankee dryers, a common approach would be phased array ultrasonic, which can look for discontinuities below the surface. This technique is better for scanning larger areas. If you had to scan a whole Yankee dryer, for instance, this would be the tool used. And then we have time of flight deflection. It also checks for discontinuities below the surface, and it's better for determining the size of the discontinuity. Okay, pressure roll load test. This test verifies the nip load, if you're at 90 kilonewtons per meter or not. The curve may say that. This test will prove whether you're at full load. It verifies zero load, how much pressure it takes just to lift the roll. It determines if a load skew exists, and it develops a load curve from accurate and repeatable measurements versus a calculation. Operational profiling, and this is a lot of different subject matter will go into this, but operational profiling, often known in the industry as OTR, generates a 3D view of the Yankee surface topography. It generates a 3D view of the Yankee surface temperature and develops a 2D view machine direction polar plot of either the topography or the temperature. And you can see here in the lower corner, this would be the polar plot generated from a single line of data, whether it be topography or temperature. Operational profiling is also a way to optimize the differential pressure or blow-through velocity. You can see here in this photo where the headers in this Yankee dryer are clearly visible. This may be an opportunity to optimize the differential pressure or blow-through. Again, this is another operational profile commonly used, and this is for crown optimization by comparing the operating profile to the grinding profile to crown specification. So a good tool for getting the crowns absolutely right. It can also tell you if there's any wear on the surface, because we don't know for sure sometimes if it's operating conditions or wear conditions. So by measuring under grinding conditions, we can separate the two and determine exactly how much wear the Yankee dryer has. And then high-speed infrared imaging or line scanning. This will check for very small variations on the shell surface, such as a through shell leak. And sometimes through shell leaks occur during operation, but you shut it down and you can't find it. This is a tool that would find a through shell leak. It can also, as the OTR, can determine if there's internal condensate system problems. Or it can also fool you because it can be a reflection of a poor profile of a sheet coming to the Yankee dryer. Each pixel in the high-speed line scanning can be used to develop an FFT analysis. So you can use the frequencies to determine any influence upstream or internal issues. So it could be a condensate system inside the Yankee. However, if the FFT shows a longer or a lower frequency, it might be the felt. And the line scanning can also pick up seams in felts, for example. Here's another image where the line scan is normalized. So you can take out the cross direction variation and create a normalized version which shows you more clearly the machine direction variation, of which we more clearly see this spot in the middle. In summary, exterior inspections can be on steel or cast iron dryers. The same with interior inspections. UT or MPI or magnetic particle can be used on both. Phased array is typically, and time of flight is typically an application for steel dryers to inspect the welds, etc. Operational profiling or on-the-run profiling looks for internal issues in the Yankee or upstream issues. And I can't see the rest of mine. Okay. Pressure roll load test, and then these two will be steam systems, and vibration will be spoken to by later participants. And so that concludes my presentation. I would next like to introduce Franz Harrer. He is the product manager for Andritz in Austria, and he will speak about steel Yankee dryers lifetime management. I'll hand it over to you, Franz.
Hello, John. Thank you very much. I'm going to start my screen sharing. Let me know as soon as you can see my screen.
It's good.
Perfect. Today I'm going to talk about Yankee dryer lifecycle management, the inspections and periodic checks. In my presentation, I like to cover the fields of manufacturing checks, so all the inspections we're doing during the manufacturing, the regular checks, which can be done by the operators themselves, inspections and periodic checks, which be done by service specialists, and diagnostic and analysis methods, but the most of them you already covered in your presentation. The manufacturing of pressure vessels, respectively the Yankee dryer, is constrained to pressure vessel international standards like the AD 2000 or the ASME or GB 150, but all these regulations and acceptance criteria are designed for static pressure vessels, so it's up to the manufacturer, the Yankee manufacturer, to develop its own more strict acceptance criteria, testing procedures to handle dynamic loaded parts as the Yankees are. As John already mentioned before, the most common test for steel Yankees, and here the test focus is on the welding seams, are the magnetic particle test, ultrasonic test, time of flight diffraction, phased array. And as you can see, we really recommend to do 100% testing of all the welding seams in longitudinal and circumferential direction. And we recommend to do MT and UT testing before and after the heat treatment to make sure that during the stress annealing process, no indications or cracks appear. The final release and certification of a pressure vessel is always done by an external accredited and authorized authority. They are observing the manufacturing process, checking all the manufacturing documentation, all the quality documentation, and perform a final water pressure test or acoustic emission test. The water pressure test is a safe test procedure for checking pressure vessels, as there is no energy saved in water compared to steam or air. Acoustic emission test is a very seldom chosen option for Yankees in the manufacturing. Before the Yankee leaves the manufacturing location, a final quality check of the Yankee will be done, containing a detailed check of the metallizing, visual, and quality parameters will be checked. As well, internally of the Yankee, the siphon system, the condensate removal system will be checked. All tolerances and dimensions will be checked before the Yankee is packed according to specification and shipped to the customer. In this chapter, I like to talk about the inspections or checks the operators can do on their own. The environment around the Yankee has to be observed on a continuous base, and all the settings have to be adjusted and corrected if needed. And it's self-explanatory that the creping doctor system has the major impact on the Yankee surface. So it has to be taken care that all the doctor settings are in best condition, means doctor loading, profiling, creping angles, and as well the interaction with the chemical coating. Inside the Yankees, steam quality plays a major role. A good steam quality control guarantees a uniform buildup layer of magnetite. This is the black oxide. This keeps the solder straws free, as we have no particles removing. As soon as we discover any red oxide or corrosion products inside the Yankee, this probably clogs the solder straws. It's important to follow the warm-up procedure when heating up the Yankee. This ensures a uniform thermal expansion and keep the stresses at the Yankee at the minimum level. And as soon as the Yankee has achieved its operating temperature, we can load the press and dry the paper on the Yankee without any danger. It's for sure mandatory to keep the press load and the Yankee pressure in the allowed range to keep the fatigue lifetime of the Yankee dryer. It's important that the chemical coating is adjusted in a good way, that the creping condition is operating well, or the creping doctor is operating well, and the steel surface or the metallized surface stays in good condition and is protected by the chemical layer. Experienced paper makers already can hear if the machine is performing well or if there are any indications, noises or whatever on rotating parts, gearboxes or bearings. But I will recommend, or I'm recommending continuous or discontinuous vibration monitoring on rotating parts to figure out if there's any damage upcoming, maintenance necessary, or some parts have to be exchanged. I'm sure all of you are aware of this, but as it is important, I like to mention it. Never cool or clean the Yankee surface with cold water. This can lead to safety hazards, injuries, or lead to operational issues as the Yankee metallizing probably cracks or breaks. Now coming to the inspection and periodic checks, which is recommended by all Yankee suppliers and the TAPI organization. For sure, here as well, the focus is of the inspection of the metallizing, a visual inspection, detailed visual inspection of the Yankee surface, followed by microscopy inspection, roughness measurement, run-out measurement of the remaining layer thickness, and so on are the main tasks of the inspection of the metallizing. Inside the Yankee, the solder straw system and the condensate removal system has to be checked in detail, but here they care only authorized and trained personnel are allowed to enter the Yankee, and all safety measures and procedures have to be taken into consideration. If any solder straws are blocked, we recommend to replace them by spare parts. If no spares are available, you can clean them with a drilling tool and can support this as well with chemical acidic paths where you put the solder straws in. And in general, if you enter the Yankee, check if there are any loose parts around, if there are any cracks or whatever. If you find some loose parts, it has to be investigated where they are coming from. They have to be reinstalled and secured in a way that they never get loose again. As the focus here is on welded steel Yankee dryers, it's strongly recommended, and in some countries it's mandatory to do non-destructive examinations of the welding seams on a regular basis. Here you can use as well magnetic test, ultrasonic test, time of flight diffraction, phased array, creeped wave, and so on, just to check if there's any indication since the last inspection. All bolts and screw connection have to be checked on a regular basis, and especially on the big parts like the decal, shell connection, UT test can be performed to check if there's any crack in the screw, and it has to be replaced. Now at the end of my presentation, I would like to talk about diagnostics and analysis. Well, the on-the-run measurement is state-of-the-art technology for advanced Yankee dryer inspections. There you will get information out of the geometry of the Yankee, how it is performing. You get a temperature profile in machine and cross machine direction. This gives you in a further step information about dewatering of or the performance of the condensate system. And you can as well discover overheating of the edges. Additionally, laser measurement to check the crown and the wear is possible. Visual checks are the most important things and should be done as well regularly by the operators themselves. And I really recommend to do audits on a regular basis with the machine suppliers, chemical suppliers, plate suppliers to optimize the conditions around the Yankee, especially in the creping area. This saves the Yankee surface, keeps the metallizing in a good condition, can increase the plate lifetime, and the chemical can be saved as well in a good way. Steam and condensate measurement is very important. This has to be done on a regular basis as well in the laboratory to check if the pH is in the right range, if there is an overload of iron or copper in the steam, which can lead to damages inside the Yankee. Well, so far that's all for my presentation. Here's my contact. If you have any questions, you're always welcome. And thanks for your attention.
Thank you, Franz. Very, very well done. Next up, I'd like to introduce Ian Padley. He's the Global Team Solutions Manager at BTG, and he'll talk about crate blade wear modeling. I'll hand it over to you, Ian.
Thank you, John, and hello everybody. Welcome from a very wet and cold evening in Scotland. Okay, I'm going to share my screen now. Let's see if we can get this up. Okay, here we go. So, as John just said, we're going to talk about
Ian, you're on mute. Ian, can you put your something?
Yeah, Zoom seemed to restart for some reason there. Okay, yeah. So I'll start again here. We're going to be looking at blade wear analysis, looking at it from the scope of process data analysis. I'd like to thank my co-worker, Dr. James Lichwalk, who helped me with the data here. In fact, what we're doing is a deep dive into some of the stuff that Franz was just talking about. He spoke about the influence of the blade doctor against the Yankee. And, oh, Agnes saying share my screen again. Okay, let me do that. Do you have my screen now?
Great.
Yes, that's perfect.
Okay,
Ian,
sorry.
thank you.
Zoom seemed to didn't like that, it restarted. Okay, let's carry on anyway. As I was saying, we were going to take a look at some of the material Franz was talking about. Get my laser pointer back. What can we learn from the blade wear? And analysing the blade wear gives us a good window on the Yankee surface. We want the wear to be slow and even. In this way, we know we're not getting adhesive wear against the Yankee, which can eventually cause Yankee damage. And we also know that we're not running on very hard coating. So if you like, we need to be in the Goldilocks zone, not too hard, not too soft on the coating. And looking at the blade wear can tell us a lot about that. Well, BTG collects a lot of blades and we analyze these, put them into a database. And what we're going to focus on today is, get a laser pointer back, here we go. The sliding wear here, the wearing surface against the Yankee, and we normalize that in microns of wear per 100 kilometer of Yankee travel. And all other things being equal, lower is a better number. So let's take a look at the first bit of data. Now, all the charts are going to be the same. On the vertical axis here, we're going to show the sliding wear. And what we're looking for are the lower values. And on the bottom, we've got the categories. In many of these, I've got three very common types of BTG high performance craping blades. And we see here that the translucent looking coating gives the low wear. That's what we're looking for. This type of low wear, the blade is staying sharp, getting good coating control, and we're not losing material to the Yankee. We're not getting adhesive wear. So the lower wear rate is good. White coating, on the other hand, contaminated with blade-eating fines and fibers, that's what we don't want to see. And very often that kind of coating will be quite noisy. The streaky coating is discontinuous on the Yankee, and that's where we start to get higher wear and the possibility of adhesive wear from, if you're using a steel blade, from metal to metal contact, which we don't want. Of course, a high-performance ceramic blade doesn't have the adhesive wear issue. Let's look at the impact then of grade and furnish. This is across all high-performance blade types. And no surprise that the virgin fiber furnishes tend to give quite low wear. One little outlier on that here is the virgin facial and handkerchief grades, where we crape quite aggressively for softness. These will tend to have a slightly higher wear because that aggressive craping maybe requires quite a harder coating. Recycled industrial wipes have quite a high wear. Again, this is the nature of the furnish coming through, a higher ash content. Virgin kitchen towel, commonly running on a great big dollop of wet strength resin, which will stick to the Yankee as well, and craping at a higher moisture, fairly low wear. No real surprises there, but it's nice to see some of our thought processes validating the data here. Okay, let's take a look at something else. What we were able to do in our database, which has got many, many hundreds of blade wear profiles in it, and data collected by the BTG field engineers around the world when they sample these blades for testing back at our headquarters in Switzerland, is we've asked them to say what type of Yankee coating is out there. Now, there's many vendors and many types of Yankee coating. So using our industry knowledge, we categorize these coatings into 3 types. The fully cross-linked or blended premium type coating. You may hear words like hyper-branched or what we say, thermoplastic coatings applied to these. The standard modified polyamide epichlorohydrin, PAE type, and the basic PAE type coatings, which are unmodified wet strength resin. Again, we've got the 3 blade types, and it's probably more clear on this one, doing a cumulative effect of all the 3 coating types and all the 3 blade types, that the A type, fully cross-linked or premium type coating, all other things being equal, is giving a lower wear rate. Well, who knew? I mean, I think the chemical suppliers have been telling us this for many years, but we would probably concur with them that in the right circumstances, the premium type coatings are going to repay that investment in terms of blade wear and the good things that come from having a low wearing blade. Again, the blade stays sharp, you're controlling the coating, you're controlling that for good crepe and maximum asset protection. Okay, we've got one more slide on this. It's quite a short presentation. There is a longer version available on the Tissue World website. It's going to be, and there's a couple of journal papers doing the rounds about this later as well. A lot more information. I've just done a short summary today. But another thing we would employ as a strategy on a Yankee is the cleaning blade. And let's look at an analysis of cleaning blade wear data. Again, lower is better. And we see that using a cleaning blade all the time appears to be a pretty good idea. All other things being equal, we're getting lower wear. Only using a cleaning blade at blade change, certainly for one of the blade types, a very common one, gives quite high conditions. And same from time to time, intermittent cleaning blade usage or never using a cleaning blade at all, we see that the wear pattern, and this is the wear on the creping blade, is generally higher. So it should be fairly common sense. If we're using a cleaning blade, we should be maintaining a nice translucent, even coating layer, and that's going to be reflected in good wear on the creping blade. Switching over to the other side here, what type of cleaning blade would you use? Well, any cleaning blade is better than none at all. A steel blade is still not as good as using a typical ceramic blade in that position. But a blade such as BTG Safe Clean blade, which is specifically optimized to work in a clean position, this by a small margin, admittedly, but this gives the best result of all in terms of keeping a good coating layer on the Yankee, and that's reflected in a good even wear on the creping blade. Well, a very, very short summary of a couple of years of work there, and many other things in the full paper, such as Yankee surfaces, use of monoammonium phosphate, add-on of coating chemical and other things. But I think you can get a flavor of it from there. If you're interested, you can go back and find the paper in the sources I said earlier. So normally at this point, I'd say something like, well, we're all here in Miami, and I hope I'll see you all on Ocean Boulevard later, but I'm stuck in Scotland and you guys are all the way around the world. So anyway, thank you for listening today. I hope you enjoyed that. I hope you found it a little bit useful, and I'll hand the show back to John.
Okay, thank you, Ian. That was great. A good summary. Hey, next we have up is something that's kind of near and dear to my heart, and something that relative to the management of Yankee dryers and inspections is the optimal function of the thermocompressor. We have Mike Susi. He's president of Cadent Johnson Systems, and today he's going to talk about troubleshooting thermocompressors. Thank you, Mike.
Thank you, John. Okay, I'm assuming you can see my screen, John?
Yes, we can.
Yes, we can, sir.
Yes. Okay.
Perfect, thank you. To start with, I'd just like to review what is a thermal compressor, just to make sure we're all on the same page. And essentially it's a device that utilizes high pressure steam to compress low pressure steam, mixes it up in the diffuser or in the throat, and discharges it at some intermediate pressure. Before we could start troubleshooting a thermal compressor, what we need to do is identify what are the operating conditions. What are we expecting from this thing? And every Yankee is unique. Every Yankee has its own siphoning system. So it's not a matter of fact that you can take say a 4-inch thermal compressor from one Yankee and apply it to another. Likely it's not going to work very well. The first step in determining the operating conditions is the condensing load. And if this is an existing Yankee where you're having an issue with the thermal compressor, doing a rate of rise test is the best tool for determining the actual condensing load. You go measure your rate of rise, how long does it take for the condensate to go up a certain height in that separator tank. And if it's a case where you're replacing a Yankee or increasing the conditions, or it's a new Yankee, we have modeling software that we can run through and determine what that condensing load should be theoretically. From there, we go on to the blow-through calculation. Once we know, assuming we know the siphon parameters and we know the condensing load, well, the difference is going to be the blow-through. And the blow-through in a Yankee can be anywhere from, from 40 to 90%. Even, I've seen some close to 100%. So that blow-through amount can vary substantially. And the differential requirement on a Yankee can also vary substantially, anywhere from the 10 to 30 psi of differential. So this is where it becomes very important to look at what are we trying to accomplish with the thermal compressor, because the whole key in making this thermal compressor work properly is that the thermal compressor curve must match the siphon curve. And going on in terms of the once we know the design conditions or the operating conditions, then there's some certain ratios that we must respect. And these ratios here, they do include some factor of safety. So if you go with these, you'll be on the safe side. But the expansion ratio is the ratio between the motive pressure and the suction pressure. And we like that to be at least 1.4, and that's in absolute terms. The compression ratio is the discharge pressure over the suction pressure. And we like that to be less than 1.9. And an entrainment ratio is really the amount of suction flow over the motive flow. And we like the entrainment ratio to be as high as possible, especially on Yankees. That's the reason why we recommend basically what we call high efficiency thermal compressors, because on a Yankee, you're limited, your motive flow is limited by the amount of your condensing load. So that's why it's important to do that rate of rise test. If the motive flow exceeds the condensing load, then we will never be able to close loop the blow through, and it's going to result in some venting. What do we mean by high efficiency thermal compressor? Essentially, in this case, and I'm sorry, all these units are in imperial units because we thought we'd be doing this here in Miami. But if we look at the suction flow, where we got 4,000 pounds per hour of flow, a conventional thermal compressor would require about 2,800 pounds per hour motive to recompress 4,000 pounds per hour of suction. A high efficiency thermal compressor would do the same amount of work, but utilize only, in this case, about 2,000 pounds per hour. So substantial savings in terms of motive. And that's why it's so important on thermal compressors for Yankee applications where we're limited by the amount of motive flow that we can utilize in a thermal compressor. The thermal compressor itself, it's the high pressure condition that determines the size of the nozzle, because that's where we're going to need the most amount of high pressure steam. But it's the low pressure condition that will determine the size of the throat in the diffuser. And that's because the low pressure condition will have the highest specific volume. So what we like to do for Yankees is to try and narrow that gap as close as possible. Try and bring your low pressure condition to be almost the same as your high pressure condition. One thing we have to be careful with is choking thermal compressors. If that range is too wide between your low pressure and high pressure range, it is possible for the thermal compressor to get into a choke condition during a low pressure condition. And what we mean here is that if you look at the vertical axis is a suction flow, and the horizontal axis is really your spindle position or your mode of flow. Well, we get up to a certain point where we get to about 2,500 pounds per hour of suction. And then if we continue increasing the mode of flow, we start decreasing the suction flow. So we're going in the opposite direction here. So we got to be aware if there is a choking condition on a thermal compressor that we're not operating it at that beyond the choke point. So in summary, thermal compressor issues can be kind of categorized in three areas. One's improper sizing. We see this quite often. If a thermal compressor is not working well, it may not have been sized correctly in the first place, or the operating conditions have changed over time. Or we've even seen some cases where a Yankee was replaced and the steam system was completely ignored. Imagine that. But it happens, we see this quite often. And when you change that Yankee, as I mentioned before, chances are the siphon is going to be a new siphon that comes with that Yankee. And it really needs to be studied to make sure that the thermal compressor is going to match that siphon curve. We often see where the mode of flow exceeds the condensing load. It seems pretty simple, but again, this is something we come across in the field on a regular basis. And that leads to the vent valve having to open to maintain the differential. The other one is more of a mechanical or erosion issue. The erosion could be from the body, where the high pressure is leaking into the low pressure section. And that could be, again, through erosion of the spindle, or it could be erosion of the nozzle itself. So what this will mean is over time, we will see that thermal compressor position closing to maintain the same blow through, the same differential across the Yankee. We often see diffuser throat erosion. And where this is coming from is typically an indicator that the separator tank is undersized, which means we end up with high vapor velocity through the separator tank, and we end up with carryover or condensate coming back up, or wet steam coming up with the blow-through steam into the thermal compressor. Over time, that erosion will increase the diameter of that throat, but also creates a lot of roughness in that throat, reducing its efficiency. And then controls. Quite often, in terms of controls, it's usually more of a transmitter that are improperly connected, or transmitter lines are partially plugged, or issues with the transmitters. Without transmitters, you're trying to control that system blind. So it's very important to make sure your instrumentation is accurate. That's all I have, John. Thank you.
Thank you, Michael. Very interesting. You make a couple of good points. I was at a mill a couple of years ago. They had replaced 10 cast iron dryers with 10 steel dryers, all vents open, and they've been blowing out steam out of all 10 machines for years, and simply didn't understand why.
Yeah, we do see that. So,
all right, thanks very much.
You're welcome.
All right, if you could stop sharing your screen, we'll get on to our final speaker. Okay, next up, and our final speaker before we get going on some very interesting real-life questions will be Manfred Jaeger. He's the managing director of Jaeger GmbH and Jaeger Inc. in North America. And today he's going to talk about vibrations, tissue machine vibrations, how to understand them and how to solve them. And at this point, Manfred, I'll turn it over to you.
Hello together. I think I have a problem with this video. It's not starting now here.
Just click on to share screen, Manfred, the big green button at the bottom of your Zoom panel, and you should be able to choose your screen to share.
Now
directly
I'm
from there.
here. Now I'm here. Now I can start the video. So. So, can you see everything now on the screen?
We can see you, sir. We can't see your presentation yet. You'll need to press the share screen button, the big green one, please. And just briefly, ladies and gentlemen, I see that Manfred is
everything.
Yes, it is. Thank you, Manfred. Just put it into presentation mode.
Yes,
and
yes.
As Manfred begins to share his screen, let me remind you all, please, to keep those questions coming. You can either use the chat box, please, or also the Q&A session, which John is moderating. And for panelists who've answered questions privately on the Q&A, please don't delete the questions yet. It'll give our audience a chance to run through them all. And John will take questions from all of us after Manfred's presentation. So Manfred, back to you, sir. My apologies for interrupting there.
Yeah, thank you. Hello, everybody together. Today we spoke about tissue machine vibration. Is this a well-balanced Yankee there? I make here a small video about a small machine to show this on this video. So
hello together. Tissue machines vibrations. Is the Yankee well balanced? Is the question. So we will show it. We have here a nice sample to show this problem. So we start the machine and running the machine to see what's happened. So what we see, oh, that is strong vibrating, the whole frame and everything. So that's not very nice. So we'll stop the machine and see what's happened. So now we disconnected the drive to see how is the dryer going. If we stop the dryer, is there some movements or something else? So now we see it, the dryer stops and reverse it. So what's happened here? We have a turning axe here from front side to drive side, and we have a mass center on drive side and also on front side. And this mass center is not here. If this mass center is not in the center of the turning axe, then we get a torque, and this torque is turning the dryer. That if this mass center is going slowly to the bottom like this, and if this is on the bottom, that means exactly below the turning axe and the mass center, and then the roll is stopping like now. So that means we must reduce, for example, the mass on the bottom, on this mass center here. Then we get this dryer static balanced. So now we can see it that the mass goes slowly down in the speed and stop and not reversing anymore. That we can do it everywhere. That means 460 degrees around it. So that means now we have exactly static balanced this roll. Now we will see it, how is the roll running dynamically, in dynamic conditions. And now we can see it. It's not better than before. Still, the roll is moving the whole frame and start to vibrate. So now what is happened here? We will stop the roll again and we'll think about it. Now we have again this turning axe, and we have a mass center on front side and drive side. Now this mass center is together on front side and drive side together. If we make from these two planes one plane, that is static balanced. But we have here two planes. That means we have on this plane and the other plane we have a separate mass, and this is now operating here on this side and on the other side on the other side. That means we get a movement like this. That's what we see it before. That means on this roll we know already how the roll must be balanced. So we make here balancing ways, the right one here on the drive side, and also on front side we install the right weights. Huh? And now we will also check it again, the static balancing, and we can see it. The roll stops also everywhere. So that means the roll is now static balanced. Now we will check it again after this balancing. What's happened in dynamic conditions. And now we can see it that the roll is not anymore moving the whole frame. The roll has a very, very low vibration, and the frame and everything is static, stable, and dynamic, stable. Thanks a lot for your interesting. I hope we have learned together something about balancing and unbalanced Yankees. Thanks a lot. Hello together.
So now we are back to the presentation, and we have here a tissue machine, a normal tissue machine. This before was a model of them, so that we can better understand on the model than on a presentation to show only the theoretical one. And I think it was very interesting to see how the machine was moving. And it's clear we do balancing. For example, the press rolls, we do every parts, felt rolls and so on, we balancing. So we have a Yankee, they have a weight of 50 to 150 tons, and we have rolls, they are from a few hundred kilo to 5-8 tons. That means these rolls are perhaps 5 to 10% of the weight of a Yankee. That means if we do on the frame of the Yankee, we bring an influence of 50 to 150 tons movement like what we see before, then makes not so much sense to looking about the small rolls. And that means the small roll starts then also to vibrate, or the doctor start to shutter marks or movements like this. And at the end, also the bearing are damages that we can see it here. We have one sample of our customer. They have doing each 2 years a bearing change after vibration checks. And now after the balancing, they're running now also 10 years without any bearing changes. so we can see it that have a big influence. And that's our question about this presentation. What is the benefit of them if we balance the Yankee? Now we can see also the advantage of the balancing. So the lifetime we expected, they go up to 20 years. Also the Yankee, if we stop it, it's a safe stopping. That means the Yankee is not anymore moving or something, that if you are do some work on the doctor, it's not risky that if the Yankee is stopped and they restarting and go backwards or something, and you have the fingers between. Also the lifetime of the covers and so on is improving. That means there is no bearings or something like this if they're not vibrating so strong. Also, of course, on the doctors, there is less movement, and that means the doctor blade is always stabler to the Yankee, means less risk for shutter marks. And this also increases the lifetime of the doctors and gives more stable organic coatings. At the end, it's also the operating window is especially higher at higher speed, bigger than before. At the end, we recommend a balancing service every 10 years to be safe that the Yankee is right balanced. So thank you for watching this short presentation. Thank you at all.
Okay, Manfred, well done as always, well explained, and the value of vibration. I've seen it before, and vibration analysis, it's just something as Yankee managers we so often overlook. So thank you for that.
Thank you also, John.
Next, we're going to get to the troubleshooting questions. And I have Michael, you're going to tell us a little bit about how to get in and vote. And I'm going to talk a little bit about how it's going to work. We have only 8 solutions to the problems that are presented. There could be 100 solutions, but we would never get the voting done. We have only 1 minute. So you're going to have to really think quick, and you have only one answer to give. And the 8 solutions we have, none of them might be the right answer. But as far as today, we're going to assume that you have to get this work done quickly. You've got the budget for only one diagnostic technique, and you have to choose the best diagnostic technique, which is presented to you from the 8. When we're complete, after each question, the votes will come in. We'll talk about what the top votes are, or the top 2 votes are. And then we're going to quickly go around the panel to Franz, Ian, Michael, and Manfred. And if they have any further comments, or if they really disagree, for example, with the audience's #1 selection, then they can elaborate on which one of the 8 they would have chosen and why.
So John, thank you. Let me jump in there if I may. And we're certainly going to go into these multi-answerable questions. It's our polling, if you will. And for all attendees right now, I'd like you to look at slido.com. You can either use the QR code that's there on your screen in front of you on the Zoom platform, or you can go across to slido.com. It will ask you for a hashtag to be put in. And obviously ours is TWDD for Tissue World Digital Days. Whilst we're getting there though, before we go into the polling questions themselves, and there are 5 polling questions that we'll run through later. John, perhaps we could go back and just do a little bit of the Q&A that's here as such. Our panelists are still with us. And I see that after a slow start, the questions started flooding in. I'm happy to ask them for you, John, if you like. Your technical experience is a great deal better than mine when it comes to Yankee, sir. So I hope I get these correct. But let's just do those questions quickly, if we may. And I saw that one of them very early on was about the actual downloading of the presentations themselves, and the presentations will be made available to all of our attendees after the webinar. So that's asked and answered, I guess. Clive, you wanted to ask Manfred a question. Manfred, perhaps you can jump in here. It was about, what do you recommend, sir, for balance grade G2.5 or G6.3? Manfred, I don't know the answer to that, but you certainly do, sir. Can I ask you to pop back in?
Yes, it's so that in the past, this was the G6.3 was very popular. Now every Yankees normally balance to 2.5. But the most problem is a lot of balancing equipment not running very fine at this low speed. The Yankees are running only at 2 or 3 hertz, and that a lot of balancing equipment not operating very well, and that's the main problem. So we find out that one or two suppliers cannot balance the Yankee very well. And so that you can see it, that's the reason we have this sample to show it. If a Yankee is static unbalanced, that if you see on site, it doesn't matter is the Yankee 2 years old or 20 years old. If the Yankee is statically running itself, that means the Yankee is not good balanced.
Lovely. And in the same vein, Fabian Danayo would like to know if you could recommend practical actions that would stop condensate or steam leaks at the lateral Yankee heads. There are some good sealing procedures. Question.
Yeah, that's so that to sealing this head shell connection, it depends. At first, it must be clear that there is no movement. That means if the Yankee itself, the shell is too stable or something like this, then it's necessary to make at first a check of the screws. That means there are many screws are leakages, or the flange and the head are leaking, and then you can decide to replace each of the screws. That means a total replacement of the screws, and you make a washer before the screws that you can pump here sealing material in. Or you have only 1 or 2 small leakages, and it's a good designed Yankee, then perhaps they have a groove between the head and the shell, and then you can pump here sealing material inside. Then perhaps it's enough like this. And also depends how is the dryer running at 4 or 5 bars, or is the dryer always running at 8 bar or something like this. Then it's a high risk if they're running at 8 bar. This is cutting everything the 8 bars. So you can cut a screw in one year or something like this.
Lovely, thank you. And I'm not sure if this question is yours. I trust it is, Manfred. Rizwan Akbar would like to know the common recommended practice for Yankee drive. He's asking whether it's single motor driven or double motor driven with a common gearbox.
Yeah, the two, if they are two drives, that means they are normally running more stable, but especially for the grinding or something, it's sometimes a big problem. If the regulator have old system, they control it, then could be happen then one drive is working against the other drive or something like this. So from this side, for grinding or something, it's not so easy with 2 drives, but normally 2 drives are much better for the lifetime of the gearbox. The reason is you have 2 drives, they put it in the torque on one gear, and if you have only one drive, the whole torque go on one point to the gear, to the main gear.
Brilliant, thank you for that. I'm going to ask Franz Harrer to pop back in. Franz, now if you would. Thank you, Franz. There were a couple of questions. I saw that you've been having a little bit of a conversation with Fabian Donayo. Fabian, thanks for all these great questions, by the way. I know you've answered them, but I'd like to just bring them into the attendees' domain. Firstly, Fabian wanted to know from you, Franz, the method that you would use for creep wave or CW regular testing?
Well, creep wave is a UT inspection method and usually used to complement to other UT testing methods like DOFT. It's used to cover near and far surface blind zones, which are not covered by DOFT or other UT inspections. So it's an additional testing.
Brilliant, thank you. And Clive Butler wanted to know, France, how often you recommend to UT the welds?
Well, I recommend to do it every 2 years or at least every 5 years, and this is matching as well the depth regulations. I really can recommend to everybody to buy the Yankee process book from the DAPI. There you will find detailed instructions for inspections and schedules. So this is a very good book. It's brand new, and I really recommend to buy this.
Lovely, thank you. Ian Padley, if I can bring Ian back into the mix, please. Ian, another question was, how would you say the recommended normal wear values in microns per 100 kilometers, are they the normal recommended wear values? And what would be considered abnormal wear?
Okay, well, these are always on a distribution, but typically for the most common type of BTG high performance blade would expect to wear between 4 and 6 microns per 100 kilometers, and
Right.
going up to anything between 40 and 100 for a steel blade. I think my sound's a bit wonky, but I have answered that on the chat box as well.
Yeah, we got you loud and clear. And whilst we got you though, Ian, I don't want you to slip away just yet, sir. How often do you recommend that you should? How often do you recommend that you should check the static and dynamic balance for a 54-ton Yankee dryer?
Okay, well, I could take a guess at that, but the expert on this question is Manfred Jaeger. So I'm going to courteously pass the question to you, Manfred.
Yes, thanks. I always, that means I recommend, if the Yankee is never ever balanced, I always do balance, at least if you can see the Yankee is self turning. And in the interval, I recommend every 10 years. Huh?
Good answer. Thank you, Manfred. And whilst we've got you online, Manfred, somebody would like to know, Xavier would like to know about the balancing class in paper and board machines. So considering the balancing class in paper and board, machines down to 1.0 and even below for some hard knit presses and calendars, what dictates the class selection? Is it perimetral speed, or is it total mass in movement, or perhaps something else, sir?
Here it gives ISO that you can read it, what the balancing quality should be. And normally G1 or something is recommended for grinding wheels or something like this. You can also use for calendar rolls or something. But if you have a roll that is itself moving, for example, a Yankee, if you measured in production, there is, for example, 0.1 run-out mistake, and you have 0.3 millimeter clearance in the bearings, then it makes not so much sense to balancing this to 0.1. To 1.0 or something, so that I recommend it. That's for calendar roll. It's a good idea, but for other rolls, it makes not so much sense. For example, for guide rolls or something, yeah, it's much more important the production of them, that the wall thickness is everywhere the same, and that the roll is not starting to moving. That means they get a movement like a banana if they're running on the high speed, and if you check it again in low speed, they're running at 0, and that makes not so much sense. Much more sense makes to the production of the roll are right good. Otherwise, you must in the center you must also balance the roll. That means if the diameter and the length of the roll is in a range, there is like a felt roll or something like this. So I not recommend to do this in a standard way. Huh?
And certainly nobody wants that banana rolling. You're absolutely right. I love that answer. Thank you. Manfred, just a quick one. And this is not a product selection scenario, but somebody wants to know if you could mention any specific sealer from Furmanite or similar to it. He says he only knows Furmanite.
What you mean? I not understand what the question.
A specific sealer from Furmanite is what the question was about. I'll ask you to go onto that and look at Fabian's question on the Q&A box yourself, sir. So let's move on from there for a moment, because you can perhaps type an answer in for me. Oh, he's mentioned now for the Yankee head leaks. So a specific sealer
for the Yankee. Okay.
leaks.
Now I understand.
Thanks, Fabian. Yeah, gotcha.
It's so that for the sealing of the Yankee, it depends. The people are thinking they can do like from outside, they can bring some plastic and could be sealing, but that makes not so much sense. Normally, if a Yankee is is unsealed, there is normally a movement between the shell and the head. That means if they go on 1 RPM over the threshold, then the shell is moving in and out. And if they start to have a movement on the shell connection, that means they start to press the shell inside the head, and they get here not a plane surface. If they deliver, they have a plane surface, but after 10 years, they get here a small crowning on this, and they're moving here. So that means if you pump it here, sealing material in, you can see it after 1 year, they started again to be unsealed there. And so that depends which kind of material you need it. And that's what I mean it before, that you change every screws and you analyze the problem of them. For example, from our company, we have exact a road book for each supplier. That means we know it, the Overmechanica Yankees, they have a special problem, or this kind of supplier have another problem. For them, we have a solution for each of them.
Great. I hope this question's for you as well. It's just come in. What do you recommend the gap of soda straws in cast iron Yankee slots should be for tissue manufacturing?
So that is also a very good question. The paper maker, they learning in the school, they should have a very close gap between the soda straw or the condensate system to the shell. That the isolation is very low, but that is meaning or learning for dryers. On dryers, you have a siphon, they go to the bottom and it's not rotating. So you can go very close to the surface and can remove the condensate. So you have no issue with this removal of the condensate. On the Yankee, the condensate go around it. That means on each soda straw, we have a dewatering and higher velocity of the steam, so that means you have a higher transferring of the temperature. So that means it's a higher temperature outside. That means you get the Yankee is moving. That means the Yankee, the run out in production is increasing. And that's also what the colleague means with the thermocompressor. Also, or John is meaning this, if they increasing the differential pressure, it's also increasing the run out. And that means if you have, from our experience, if you have a normal thickness of the coat of the shell, you should have 6 millimeter distance. And if you have an old Yankee with a thin shell, you should have 7 to 8 millimeter distance. That is, would say, the optimum from the heat transfer to the run out, and also with the differential pressure. Huh?
Marvelous. Thank you, sir. Appreciate that. That's awesome. I'm going to bring in Mike Susi, if I may here. Mike, I know you've answered a couple of questions as people were chatting away, but just for the generic audience here, somebody wanted to know the typical life or approximate life of a thermocompressor on a Yankee dryer. And how often should a thermocompressor be inspected for erosion or wear, or even its own internal conditions? Approximate life, please, for a thermo.
Thanks, Michael. Yeah, typically what we would see from a expected life of a thermal compressor is somewhere between 15 to 20 years, if everything is working properly. And if the first inspection, if there's been no issues whatsoever, it's not a bad idea maybe to have a look at it at about 10 years, just to see how the life of it, and internal inspection to see if there's any holes worn or anything erosion occurring, because it's an opportunity for you to start, thinking about maybe a replacement or troubleshooting the system to see why the erosion is occurring. One thing I forgot to mention earlier is that quite often erosion may also occur from the motive side, where we may have wet steam coming in from the motive side. So that's also another potential erosion through the nozzle.
Whilst we're talking about that, Mike, and thank you for clarifying there as well. Doug Holderman was asking about thermocompressors, and he said, look, he knows there's certain recommendations for the amount of straight piping that lead up to the thermocompressor. He says he's worked as a mill where the optimal pipe run simply couldn't be achieved. How much of an efficiency loss would you expect in the ballpark on straight piping? What do you normally like to see? What's critical, what's not so critical?
Yeah, I'm not sure if he's referring to the suction side or the discharge side of the thermal compressor. On the suction side, it's not that critical. Typically, if we have 3 to 5 pipe diameters, we're pretty happy with that. And there's normally on the suction side, there's a check valve near the thermal compressor as well. The efficiency there is relatively small loss on that. You may lose maybe a 5%, something like that, if you can't quite follow good piping practice. What's more critical is the discharge side of the thermal compressor. We do like to see 10 pipe diameters on a discharge of straight pipe without fittings or anything, any obstructions. And for the first fitting, if that could be an elbow as opposed to a dead T or something like that, where you can get some like rebounds back towards the unit, that's an advantage. If the poor piping practice on the discharge side, that could really affect the efficiency. You could reduce your efficiency by 15–20% with poor piping practice on the discharge side of the thermal compressor.
Wow. Okay. Thank you for clarifying all of that. I appreciate it. We'll give you a bit of a break, sir, and just bring up, we're looking for Ian, please, if we may. Mr. Padley. I know
Hello.
You've typed an answer for this briefly as well. Hello, sir. Welcome back. The question was from Clive Butler, talking about the average wear data, excluding edges on the blade, or the is the wear data on average wear on the blade or on the worst area? How would you answer that one?
Okay. Well, hi, Clive. If I shout loud enough, you may hear me here without the mic anyway. But no, good question. So it slightly depends on what the specifying engineer on site does. But typically, we would ask for either 3, 5, or 6 wear points to be measured by the lab inside the paper area. So we exclude edge wear on the blade, which is always extreme. We'd take those 3, 5, or 6, and we would do the average of those. But what will happen very often is if the specifying BTG engineer is seeing a streaky, obvious wet patch on the Yankee, he'll probably ask for or she would ask for the sample to be taken there for the lab. And so we would get that kind of data where the wear might be quite high. But then that's reflected in the results I've been presenting anyway. Hope that answers the question for you.
It certainly does. Thank you very much indeed. And to all of you gentlemen, thanks for running through those answers to some really interesting questions. I'd like to move now, as you can see it on the screen, into our questions, if we may, where we can get some information from you. And as John says, we'll hand back to him in a moment once these questions have been answered. But if you would, please look at hold your phone up, or your smart device, if you will. I held mine over the scan code on my screen. It immediately brings up slido.com. Under polls, if it opens in Q&A on the left side, please just press it over on the right-hand side. And the first of those questions, or if you've gone in via the app at slido.com, you would just have to add the hashtag to TWDD. Here we go. The scenario 1 question is up there now. I hope you've got it on your devices, as I have. The 8 multiple choice questions for you are there. And basically, what I'd like to ask you on the first question is, a cast iron Yankee dryer has been in operation for several years. Let's assume that it started experiencing out of round events about 6 months ago. That event would start seemingly without any process change, but the press would violently shake, the sheet would break, and the only way to stop it was to take the sheet condensing load off the Yankee itself. At first, that started as an isolated event, but now it's happening about once a week. And guess what? The boss wants it fixing ASAP. And out of round is an extremely high operational Yankee runout. Would you pop your answers into the app for me now in terms of our scenario 1? The answers could be number 1, would you go for an exterior inspection on the steel or cast? Number 2, would you go for an interior inspection on the steel or cast? Or number 3, would you be using UT ultrasonic and MPI magnetic particle phased array PA or time of flight diffraction ultrasonics? Do you think the answer ought to be operation profiling, high speed infrared, or on the run profiling? Or number 6, complete steam system analysis? You've got 2 more. It could be complete system vibration analysis, or number 8, the pressure roll load test. So would you pop your answers into the app there, please, at that level? And then just press the little green button at the bottom of your app for send. And when all of this comes through, we'll be able to get our notes and finalization on this, and we'll be taking you through with John and our panelists, the overall thoughts and findings. So let's go over, if you've answered that one now, into scenario 1. We've got 16 answers coming in. You can all do better than that, folks, 17. So they're slow, but let's bring them through. 18 answers coming in.
Michael, we were thinking about 60 seconds time limit.
Gotcha.
One minute time limit, and then the voting is over, and we'll talk so that we can move through as many as possible.
Well, we've done over 60 seconds on this. Thanks for the timely reminder there as well. Let's jump into scenario 2, please, if we may. The voting has closed on scenario 1. Let's go into scenario 2, if I can wait to see the question there as well, please.
And Michael, let's do 60 seconds after you've read the question.
Thank you. I'm just waiting to see the question up on screen before we reveal the results or anything that's there. That's coming up for us now from Central Control. Oh, it's one of those multiple choice things where you have to guess the question, I guess. Here we go. Just waiting for the question to be shown up for us. Q&A is open. Right, scenario 2, there we are. They've got 60 seconds to vote on this once I've read the question. Here you go. A dust fire breaks out on top of the hood. And as the cinders begin to fall, the fire quickly spreads. The hoods have to be shut down immediately, and the Yankee is left running. The fire department alarm gets yanked. The fire grows and runs down the cable trays to the point where the paper makers can no longer control it. It takes 8 minutes before the fire department arrives and clears the building. The last operator out of the control room hits the e-stop. And the next morning, when it comes to assess the damage, the machine will be down for a month to rewire it entirely. The boss wants to know if the cast iron Yankee is safe to start up. There are your 8 answers on the screen for you. I'll run through them briefly. You have 60 seconds from now. Do you go for exterior inspection? Do you go for an interior inspection, an ultrasonic and MPI magnetic particle? Number 4, you might be looking for a phased array PA or time of flight diffraction ultrasonic. Number 5, is it operational profiling? Number 6, complete steam analysis. Number 7, complete system vibration analysis, or indeed the last option that's there for you as well. Number 8, let's now have a look at the polls on there. And I need to bring up question 3 as voting closes now in 10 seconds or so on question 2. Agnes, would you be able to bring up the question 3 for me, please? Here we go. Scenario 3 coming up. Number 3, a cast iron Yankee dryer has been plagued with out of round issues for years. There were 4 shell mounted headers with vertical straw pickup points. The mill decides to upgrade to a 6-header condensate system with 2 pickup points as an outrigger per header. The machine starts up, the profile's perfect, there's no out of round conditions, and you're building up to 60 meters per minute. Maintenance reports increased vibration of both the pressure roll then and the Yankee. So we see the sheet blistering a few times a day, sometimes on the front, sometimes on the back. And obviously that's caused significant efficiency loss. The boss wants it remedied, and slowing down to the former speed is no option. Number 1 to 8 in terms of your answers. You've got 60 seconds to answer these, please. Is it exterior, steel or cast for the inspection? Interior, steel or cast? Is it the UT ultrasonic and magnetic particle phased array, PA, or time of flight diffraction ultrasonics? Maybe it's operational profiling on high-speed infrared or on-the-run profiling, or complete steam analysis, or number 7, a complete system vibration analysis, or last but not least, is it the pressure roll load test? Right, we're going to close voting on that in just a second, and I'm going to ask Agnes to show us scenario 4. We have 2 more to go, ladies and gentlemen, and this is the second last of these. Number 4, during an emergency shutdown, a steel Yankee stops, but the hoods don't retract, and they remain in high fire for about 4 minutes before finally being shut down manually. It's suspected that the temperature limit on the Yankee has been exceeded, at least where it's exposed to the hood, and upon startup, the press is loaded but starts bouncing. Paper production is barely possible. What's the first thing you do to understand the extent of the problem and the potential damage done to the steel Yankee? There are your 8 answers again there. Choosing from any one of those 1 to 8, the answers by now should be familiar to you, at least in terms of the options. Please vote now and tell us what it is that you would do to answer scenario 4. I'll give you 5 seconds more on that. Thank you. Let's go over and vote now on our final scenario polling question, scenario 5. Here we go, number 5. A tissue machine with a cast iron Yankee has changed from virgin to recycled pulp. The base weight, the speed, and the hoods, though, have remained constant. The steam pressure's been increased, and the steam system operates in a differential pressure control. However, the condensing load has increased from 3,500 kilograms per hour to 4,100. There's a consistent wet streak developing on the center, and vibration has increased on the Yankee, the pressure roll, and doctors. Your blade life is now half, so in order to keep the Yankee from flooding, the atmospheric vent is now opened 20%. The boss clearly wants to stop sending steam dollars out of the roof and return the blade life to its historic average. And guess what? He wants it immediately. Your answer, please. Choose from number 1 through to number 8. Love these scenarios. Whoever planned these really put them together well. Thank you. Right, we're voting on those. And John, I'm about to hand over back to you, sir, if I may. Just Jeff, very briefly, Jeff Peters put a thing up earlier saying he lost the ability to vote. I think just reboot on the app and you'll have an opportunity, or at least, John, stay with us and understand what your colleagues are saying at these levels. John Holton, over to you.
Okay, thank you, Michael. Well done. And Agnes or Michael, let me know how we're going to show the results of scenario 1. And I'm not sure if we can put the question back up there next to the next to the voting.
Agnes is controlling, so we'll find out how we operate that from Belgium.
Oh,
Here we
this
go.
is super. Okay, scenario 1, and we've lost the scenario 1. I thought I saw it for a moment. Okay, let me just
I'll ask Agnes to put the question back up for scenario 1 and then chop away to the answers. And each case that would help you.
yeah, if we could just flash to the scenario 1 and then we'll go through the answers. Okay,
There
this
we
is
go.
the one
Number
where the
6 was
cast
the most
iron
popular.
dryer started experiencing out of round conditions, which continued to get worse over time. So that's the summary of that. It's been in operation for 20 years and now the problem starts. So let's go back to the answers.
Won't take a second just for us to bring those up. It looked like number 6 was one of the most predominant answers there while we're looking at them, John. Let's see how those answers come up. You may, John, as well be able to go to the app itself on Slido. I'm looking at the answers coming through very strongly, 56%.
Oh, got it. Okay.
There you go.
Answer number 1, or scenario number 1, we had 56% of the audience which said complete steam system analysis and 44% operational profiling. And personally, those were the top 2 on my list. I have no arguments with any of that. Let's go around the table in the order of presentations. Franz, Ian, Mike, and then Manfred. Franz, any comment?
Well, looking at the voting, I would go into the same direction. First, I will do an operation profile on the run measurement to check, okay, how the surface is looking like, where we have the run out deviations. Most probably it's coming from the steam system inside. Probably there is a crack in a riser pipe or something like that. So a check of the complete steam system would be recommended by my side as well.
Okay, Ian, any further comments?
I think the audience was spot on. I mean, the giveaway is the fact that you take the sheet off and it returns. So it's clearly you need to look at the steam and condensate system, but I agree with Franz. It's good to do that in conjunction with an on-the-run diagnostic, and then you can maybe able to isolate where the problem is to a specific header or a riser.
Thank you,
Yeah,
Ian. Go ahead.
I agree, but I would do the OTR at first to save the money, to see it, what is happened. If I stop the machine, I must need 12 to 24 hours to cool down the Yankee. Then I go inside for 12 hours, and then perhaps I find nothing, and I restart the Yankee, and I have still the same problem. So it's better for me to make at first the OTR to find it out. Is it really a problem of the condensate system or something else? And if it's a problem from the condensate system, I'm not losing any time before, and then I can planning to stop the Yankee, and then I stop it. I have a Yankee cooler and everything on site, and then I can cool down in 12 hours and can do the job. Huh?
Good point, Manfred. I mean, those are 2 things that you would want to do, and I agree. I would do the OTR first. However, eventually, as you say, you need to find the extent of the problem and understand it more to direct your second step. So good point. And Mike, steam system analysis came up first. What do you think? Any further
I agree with
comments?
that, John. And for me, it would be like that internal inspection of the siphoning system. Have a good look at that. We've got, is there something, cracked or plugged or something gone, that's not quite right with that.
Okay, fantastic. Let's, Manfred, do you have any further comments?
No, it's fine.
Okay, perfect. Let's go to scenario 2.
Thanks, Agnes. If you'll bring up scenario 2 for the question for us to show it through there.
No.
John, are you seeing scenario 2 on the screen?
I am still seeing scenario 1.
Myself as well. Sorry, Agnes. I know you sent me a message saying it's showing on the screen. I think you may have to share screen to bring it up. Maybe you could just move on to scenario 2 for us, please. I see Jeff Peters has put a note up saying it's on his screen. John, I still don't see it on mine. Do you see it on yours?
I do not.
Jeff, if you can, I'm struggling to see that. My apologies. It's blinking. I don't see it.
Jeff, are you seeing it on Zoom or are you seeing it on Slido?
Apparently some of our delegates are now seeing scenario 3. Not me, however. I don't see it at all.
Probably, John, you can read scenario 2 in between until we're waiting for...
Yes, yes. Okay, scenario 2. And then if we can bring up the Slido, this is all we need. But this is where the dust fire breaks up on top of the hood. And everybody leaves the building. Nobody knows what the fire department did. They don't know how much water was sprayed around. But this was a massive fire. So we want to know a month from now, is the Yankee safe to start up? And if we could bring up the answers for scenario 2 or the results, then we can go around and have the discussion.
Apologies, John, I can see your title slide up there. I'm even looking on the app. I can't see it on Zoom at the moment. It's disappeared from Zoom. And I'm waiting. I can see voting closed on the polls, but I can't see the results of that. I do beg your pardon. Screen sharing coming up. Here we go. There we go.
Yay.
Results to number 2. Now I can see them on the app as well as on Zoom. Thank you.
Okay, excellent, excellent. Again, this is the big fire. The number 1 answer with 56% is UT ultrasonic, MPI magnetic particle, and then phased array or time of flight diffraction. And this happened to be a cast iron dryer. So I'll start it off with, and I may have not mentioned that, but I have nothing further to say. I think the top 2 votes are good. Ultrasonic in this event, this is exactly what we did with the ultrasonic, and the magnetic particle inspection was the course that we took. Franz, any further comments?
No additional comments from my side. Phased array would be a good opportunity to make a fast check of the structure of the cast Yankee, and ultrasonic magnetic particle are fine as well. So it should be really investigated in detail if there are any defects, cracks or whatever, especially as we have a cast Yankee. It's very, very critical.
Thank you. Ian, further comments?
No, nothing to add. Just not my field, but it's clear you need to look at the metallurgical structure of the Yankee with a non-destructive testing method. So there you go.
Very good. Mike, comments?
John,
Yes.
Generally, I agree, but I think I would do at first also the OTR. That means I measuring the runout and these things, and then I see exactly what's going on which. If the runout is nearly zero, I not need any other checks. If I see on the runout some mistakes, I see exactly on which point the mistakes are. And on these points, I can make the ultrasonic and the magnetic tests. And then I know exactly on these points, there is some mistakes or there is cracks or something else. Huh?
Okay. Thank you for your comments. And Mike, anything to add?
Nothing from me. Thanks, John.
Okay. Yeah. Manfred, any further comments?
No.
Good. Okay. Let's move on to scenario 3.
Scenario 3 coming up now.
Hey,
There we go.
there we go.
That's
Okay, this is the one where the Yankee dryer has been plagued with out-of-round issues for years. There were 4 shell-mounted headers with vertical pickup points, and the mill decides to upgrade to a 6-header, 2 pickup points per header, so 12 pickup points. And the goal was to make it stop going out of round. Machine starts up, profile's perfect. However, there's increased vibration throughout the machine. The sheet is blistering a few times a day, sometimes on front, sometimes on back. It's random, and the efficiency has dropped. So let's see what the audience said that they would do first in this scenario. Operational profiling and complete system vibration analysis. Both great answers. I couldn't make an argument with either one. So let's go to Franz. Any further comments?
Additionally, I would do an inspection of the complete steam system to evaluate the blow-through steam and the temperature distribution on the surface. This can be done as well by an OTR, as was the answer number 1. But additionally, I really recommend to check the complete system and do a calculation as well.
Very good points. We don't know if the flow characteristics of the new system match the old system. So that may be part of the problem. Operational profiling might give us some ideas there as well. Ian, further comments?
Yeah, I completely agree with Franz there. And what I'd be doing on the diagnostic, as well as checking all the steam flows, is using a high-speed infrared. This gets to the bottom. It's a thermal issue, right? So you do it with the steam and you do it with the high-speed infrared, and you'll nail it pretty quick doing it that way.
Yeah, very, very good point. If you combine the infrared along with the OTR profiling, that gives you a good idea of the origin of the problem. Mike, any further comments?
No, it's already been well covered.
Okay, and Manfred?
Yeah, I'm the same opinion. That's a good way.
Great. All right, thank you, gentlemen. Let's go on to scenario 4. Okay, this is an emergency shutdown. The steel Yankee has been stopped, but the hoods aren't retracted and they remain in high fire for 4 minutes. It's suspected that the Yankee temperature limit was exceeded during the event. It's not known, it's expected. So upon startup, the press load and press is loaded, everything starts bouncing, and it bounces so much that paper production becomes minimally possible at a slower speed. So what do we do to understand the potential damage of this steel Yankee?
Let's take a look up at those answers if it's possible. There we go.
Okay, wow, okay. So we have a tie vote here, basically, at exterior inspection for TIRs, etc. That's a good answer. And then also the very powerful tools of operational profiling with infrared or on the run profiling. We have a very close third. and I can't argue with this one either. But phase array, this is a steel Yankee dryer. We may want to understand, have the welds been affected by that event? So I just can't argue with any of those. Franz, further comments?
Here, I completely agree with the audience. Exterior inspection and operation profiling would be the right way to go in the first step.
Excellent, thank you. Ian, comments?
Yeah, in this situation, the first question to ask is it safe? So that the methods outlined, but particularly the non-destructive testing, take you in that direction.
Okay, thank you. Mike, any further comments?
No.
Okay, and Manfred?
I totally agree, but I would do additional, if the hood is burning to the dryer, so the dryer is very have a very thin wall thickness, and the heads are very thick, so that means the shell itself is growing outside. That means about 100 millimeter from the edge, or up to 150. There is a bending area of the steel. So that means if steel Yankees are sprayed, so the spraying material get perhaps some small cracks there, and they should be also check this area, that there's small cracks or something in the spraying, or the bounding is losing or something like this altogether. Huh?
Very good, very good. And let's move on to scenario 5. It's our last one. I want to do a time check with Agnes. And do we want to go into this one? We'd like to have a chance to thank our sponsors at the end, but this is maybe 5 minutes.
I think we can actually share that information, but it's up to Agnes and your call. Otherwise, we'll share it and I'll go in for a wrap up, as we are marginally behind time, but it's up to you. Agnes, please make the call.
Yes, I think it's fine. I think it's another.
Great. We're on our last one. So here we go. This is the one of the cast iron dryer has changed from virgin to recycled pulp. Recycled pulp is higher fines. The dryer is working harder, and the condensing load is increased from 3,500 kilos per hour to 4,100 kilos per hour. We now have a consistent wet streak at the center. Doctor life has dropped. And we have to keep the vent in the roof open in order to keep the dryer from flooding. So let's see what the audience said. Okay. Again, both good answers from the audience. Number 1, complete steam system analysis, followed by operational profiling. Can't argue there. Franz, any comments?
Here, I completely agree with the audience. The internal parts of the Yankee has to be checked, and the steam and condensate system has to be investigated.
Okay, thank you. Ian?
Yeah, I've done a few like this actually, but yeah, exactly the same as that. Same as Franz, same as the audience.
Thank you, sir. Michael?
Yeah,
Comments?
I also agree with the audience. In this case, it's a significant increase in condensing load. So it appears that thermal compressor is no longer matching that siphon curve. That could be one of the reasons why it's venting. It was mentioned, to look at the siphoning system in terms of adequate capacity or differential pressure requirement for this new condensing load. But you got to look at externally, external piping. Are we now overwhelming the existing piping with this increased condensing load? Usually comes a increased blow through as well, increased differentials. So the system needs to be looked at as a whole, starting from the siphon, looking at the piping, the separator, and back up to the thermal compressor to close that loop.
Okay, thank you, Michael. And Manfred, we'll finish up with you and your comments on scenario 5.
Yeah, I also agree, but I would do it like before. I would do it OTR together with the complete steam system analysis, then I can compare it. What is the temperature of the Yankee is doing if you're changing something on the differential pressure, or to see it, how is everything working together. So I think it's a save time and is more efficiency.
Excellent, agreed. So, okay, that completes our Q&A, and to close us out, Michael, I'll turn it back to you.
Wow, thank you very much indeed. And one or two technical problems adrift there, for which we apologize, obviously, to our audience. Thank you for staying with us. It was wonderful watching that actually at the end, because normally, we get the audience to agree with the experts. And this time round, our experts were agreeing with the audience. So if you got all those questions correct, give yourselves a pat on the back for that, because really there was some tricky but kind of testing things to work your way through there. And I think you all did a really phenomenal job. Our time has flown by. I apologize for slightly overrunning, ladies and gentlemen, but that's what happens when the quality of the discussion in your industry engages you like this. I want to thank each and every one of you for all of those questions, and a massive thanks on behalf of TW for you for taking part, to both our presenters and of course you, our delegates, most importantly. The networking on this platform continues over the course of the next 2 days as well. And this is the reason significantly that we wanted to go digital for you in these times of the pandemic, pre the vaccine. And it hopefully will make sure that you can take full advantage of the digital opportunity over the course of not only today, but tomorrow and the next day, to meet with, to network with, and engage with your industry colleagues from all around the world. I have to thank our sponsors once again who've helped bring this platform to you. Our platinum sponsor, of course, Solar Turbines, and even our gold sponsor, Buckman, as well as our silver sponsor, Jaeger, who offer North and South American tissue manufacturers a unique and all-inclusive service package for Yankee dryers from its new US-based service facility, and has made a global name for itself as a highly innovative, reliable, and effective for the tissue industry. I believe we have a really short video from Jaeger, and if we have, and we can roll it please from the background, let's just take a quick look. I think it's about 15 seconds long. Here we go, and then I'll come back and wrap up with final close for you.
Die Musik.
I think we're struggling on the sound there as well.
That's a new time edge grinder to analyze it first, like a OTR, the surface, and then to grind it only the high spots. That's the time edge grinder.
Thank you so much for filling us in on that. I really appreciate it. Sometimes the technology gods align, and sometimes they give you one or two headaches. To all those of you who stayed with us right the way through from the beginning of this broadcast, again, our abject apologies. Wow. We ran one this morning in Asia that worked superbly well. Maybe we were all a little overwhelmed with what was going on in the internal dynamics of the Yankee dryers. I tell you what, though, come back with us tomorrow. We'll be starting tomorrow, 2 o'clock Europe time, 1 o'clock in the UK, 4 p.m. Istanbul time, and we'll be moving strongly into a focus on Turkey and the Middle Eastern market segments. I'd like to thank you once again and say good morning, good afternoon, or good evening to you. We look forward to seeing you tomorrow. Make sure you take full advantage of this platform. Go and meet some of your colleagues. Thanks a lot, and thank you for joining us once again.